Hi all. So now we're going to take a look at rational exponents. Okay, that's when you have a fraction in the exponent. So to do that, we're going to look at this idea. The nth root of a would be the same thing as a to the 1 over n, where your n is in the denominator there. That means you've got a square root. Or, excuse me, not a square root, but a root. Okay, so if it was, say, that was an understood 2, then you'd be looking at a to the 1/2. If that was a 3, then it'd be a to the 1/3. You get the idea. So based on that idea, I've got 1, 2, 3, 4, 5, 6 problems here for you to try out. Go ahead and hit pause and see if you can get these guys based on this idea. Okay, awkward silence, done. Hopefully you hit pause and you try these out and see how you did. Let's see what we get here. All we're doing is we're taking the radical notation to rewrite each expression and then simplify. So this guy can rewrite as the square root of 25, correct? And of course the square root of 25 is 5. This guy here becomes the cubed root of 27, right? Cubed root of 27 is 3. Now I'm curious how you guys did this one. The negative 25 to the 1/2 power. Did you get not real? If you did, you're wrong. Okay. So let me show you the right way first. What's happening here is it's really saying the same thing as a negative of 25 to the 1/2 power. Okay. Which then you can rewrite as a negative square root of 25, which becomes the negative 5. Okay, so you may be thinking at this point, well, wait a minute. If that was real and it worked out okay, then which one's the one that's not real? Okay, maybe put another one in here. Suppose we had a negative 25 in parentheses raised to the 1/2 power. Okay, that would be not real. So it boils down to whether it has parentheses or not. Think about it this way. Exponents are short-sighted, okay? They wear glasses. I'm short-sighted. I have to wear glasses so I can see far away. So you have the negative square root of 25 to the 1/2. This 1/2, it doesn't have glasses, so it's only seeing the 25. And it says, oh, okay, you know what? I'll just take the square root of 25. And then it figures it out. Now, suppose that you had glasses on this thing. Okay, parentheses are the same thing as glasses, and ooh, there's a negative there. Okay, then that's not real. See the point? If you wear glasses, or assume that the parentheses are glasses, if they're not there, then the power is only seeing what's right next to it. If it's wearing glasses, or if it has parentheses, it's going to see all the way out here. Hopefully that helped alleviate that if you got that one wrong. All right, negative 27y to the 6th raised to the 1/3 power. Cube root of a negative 27 is a negative 3. And then this is like saying 1/3 of 6, which is 2. So that's just y squared there. So negative 3y squared. Oh, I didn't show that extra step, did I? Let me show that. Sorry about that. So this would be the cube root of a negative 27y to the 6th, which then becomes negative 3y squared. All right, this guy here, well, x to the 1/5 becomes the 5th root of x, and I cannot simplify that one anymore. Now remember, on this next one, 7x to the 1/5, what's that 1/5 seeing? I mean, how much is going to be inside the radical? Will the 7 and the x be in the radical, or just the x? If you said just the x, then you are correct, because this power only sees what's next to it, because I don't have parentheses there. So it's going to be 7 times the 5th root of x, right? If it was 7x quantity to the 1/5 power, that would have been the 5th root of 7x. Okay, so these parentheses are really, really important when you're dealing with these sorts of problems. I don't know if you picked up on this yet, but we're working our way to some bigger fish here. But well, let me get us to that point first.